Hi, in this video we're going to cover the topic of ratios and rates, which is Chapter 5, Lesson 1. As is often the case in beginning lessons, this has lots of terminology in it. So that's the main thing, is focus on vocabulary. So I wanted to have some things up on the board to start with, so I don't have to be writing them down as we go. A ratio is a comparison of two numbers, and those two numbers either have the same label or they have no label at all. Sometimes the labels aren't exactly the same, but they're so close that you can kind of consider them to be the same. And there are three ways to write ratios. You can write it with a fraction bar, 5 to 4, or with a semicolon or a colon, 5 to 4, and just write 5 to 4. But each of these you read is 5 to 4, 5 to 4, 5 to 4. This could be 5 feet compared to 4 feet. If you're comparing someone's high jump results, one person can jump 5 feet, another 4 feet. So that would be just the ratio of those two numbers. An example of ratios that labels aren't exactly the same, but they're really close, would be a class of 9 people has 5 girls and 4 boys. And consider that they're both people, so they're very similar. That's often considered a ratio. If you're comparing two numbers and they have different labels, and this may seem technical because it is, that's technically considered a rate. It behaves just like a ratio. It's a comparison of two numbers, but those numbers have different labels. So 20 points in 5 games is a rate of 20 points per 5 games. 50 miles for every 5 hours, or 100 miles, you can travel 100 miles on 4 gallons of gasoline. Your rate would be 100 miles, 100 compared to 4. Those numbers are more meaningful, those comparisons are more meaningful when they're expressed as unit rates, which is a rate where the second number, if it's like in a fraction, it would be the denominator, is a 1. And it's fairly simple to convert these rates to unit rates, because all you need to do is 20 divided by 5. So this would be a unit rate of 4, and it's often written this way, points per game. And that means points per 1 game. You reduce these the same way you reduce fractions. We have to divide by 5, and we get 4 over 1. So it's 4 points for every 1 game. Divide by 5 again, you get 10 miles in 1 hour, which is 10 miles per hour. Points per game, miles per hour. If you go 100 miles on 4 gallons of gas, you have to divide the bottom, even instead of a decimal number, you have to divide this number into the first number in your ratio rate. So this would be 25 miles per gallon. Or you could write 25 miles over 1 gallon. That actually looks more like a unit rate. So technically that's probably how you'd want to write it. 25 miles per 1 gallon. And really only one more thing in this introductory lesson is to talk about conversion factors. Make a little space here. Conversion factors are rates that are always equal to 1. They're like a fraction that equals 1. But it won't be obvious that it equals 1. Here's an example. 1 mile is equal to 5,280 feet. So this number actually has a value of 1. I could put, where I have 1 mile, I could write 5,280 feet and say this is the same as 5,280 feet compared to 5,280 feet. And just like we can cancel out the numbers, we can cancel out labels. So this equals 1. What happens when I multiply anything by 1? I get what I started with. So you can use conversion factors to convert from one kind of value, one kind of measurement to another kind of measurement. So I'm going to use that conversion factor of 1 mile for every 5,280 feet to change 30,000 feet to miles. So I know that I can multiply 30,000 feet by 1 and it'll still be 30,000 feet, or have a value of 30,000 feet. This is a 1. So if I multiply these two together, this will happen. The feet will cancel because units cancel just like numbers. And I can multiply 30,000 times 1 times 1. And I get 30,000 miles, because this is important to that label. And 1 times 5,280 with no label now, because these labels canceled. When I do this arithmetic, which I'm not going to do all that, because it's really about the process here. When I do 30,000 divided by 5,280, I'll get a number about 6, because 5,000 goes into 30,000 6 times, a little less than 6, maybe 5.8. It's about 5 and 8 tenths miles, just an estimate, which is reasonable. 30,000 feet is a little more than 5 miles, between 5 and 6 miles. But the important thing is here, this is a unit rate, a conversion factor, and it has to be equal to 1. And I can multiply any number by 1, and maybe it'll change the way the number looks, which is what I want it to happen anyway, but it'll still have the same value. You do this in fractions all the time. If I wanted to double the numerator and double the denominator, I multiply by 2 over 2, well that's 1, but I get 10/16, which equals 5/8, it's just written in a different way. It's the same idea. 1 gallon. Do you remember how many quarts that is? Oh, it said 4. I can put 1 gallon right here and have 1 gallon over 1 gallon, that's 1. Or I can put 4 quarts in for 1 gallon and have 4 quarts over 4 quarts. That has a numerical value of 1. So if I have 17 quarts, and I want to know how many gallons it is, I can just multiply it by 1 gallon for every 4 quarts. But notice that I chose that deliberately because I want the quarts label to cancel out. Let's put this over 1. So I can cancel these labels, and it leaves me with 17 gallons over 4. 17 over 4 would be 4 1/4. So 17 quarts is 4 1/4 gallons. If I wanted to change gallons, if I start with gallons, and I want to convert that to quarts, I have to flip this conversion factor and make it 4 quarts for every 1 gallon. Because I want the label of gallons to be the label that cancels out. It would give me 20 quarts, 5 times 4. 5 with no label times 4 quarts with a label would be 20 quarts. And 1 times 1 is 1, so it's 20 quarts over 1, which is 20 quarts. Now you intuitively might know that, because if you know there's 5 gallons and every 1 gallon is 4 quarts, your intuition is probably going to tell you you're going to multiply 5 times 4 to figure out how many quarts it is altogether. And intuition is a good thing, but understanding how this conversion factor works will help you solve difficult problems that you might look at and say, I don't know how to do that, but I do know how to use conversion factors and can figure it out.